Do all preamps work with all power amps? What if the colors clash? Hi, welcome to Lancaster Hi-Fi. I'm Stephen Lancaster, and I want to talk today about compatibility between preamps and power amps. If you have a nice preamp and you have a nice power amp, will they always work well together? And always is a strong word, so, probably not always. Maybe usually, but maybe not always. Anyway, what are the big issues? I would put it down to three main issues. Preamp output level versus power amp sensitivity. Preamp output impedance versus power amp input impedance. And preamp and power amp frequency responses. And then I'll throw in a sort of a fourth item of, are the frequency responses impedance dependent? Are the impedances frequency dependent? Okay, so there are complications, but I think those three are the big three. And finally, how are you going to know? How are you going to know whether, before you listen, before you buy? And there are things to look for, and I'll get to those. All right, so first let's talk about preamp output level versus power amp sensitivity. And this is one that I have struggled a bit with. And the basic issue is usually, does your preamp have a high enough output level to drive your power amp to full power? So say, for example, ideally, I've got a line level out from my preamp, and that's maybe 2 volts RMS. And I have a power amp with a sensitivity of 2 volts RMS or less. In that case, then my preamp can drive my power amp to full power. But what if I've got an old receiver? It's got a preamp and a power amp. Can I use the preamp outs to drive a separate power amp? Well, sometimes you will find that those built-in preamps on receivers and even integrated amps might only have an output level of around 100 millivolts. And in that case, you better have a super sensitive power amp if you're going to want to drive that power amp to full power with that preamp. That's most often the problem. For example, I built a power amp that had a relatively low sensitivity. That is, it required a relatively high output from a preamp to drive it to full power. And so I struggled a bit with finding a preamp with a high enough output level to drive that power amp to full level. You could have the converse problem where you have a very high sensitivity power amp. That is, it requires a relatively low input level to drive it to full power, and your preamp has such a high output level in general that you're pegging your power amp when you turn up the volume to 9 o'clock. And so you're like, I don't have enough, my volume knob is essentially too sensitive. I can't get it to the level that I want. And that can be an issue. That's a relatively straightforward thing. You do have to look into the specs, right? You do have to look into the specs of your power amp. You do have to look into the specs of your preamp and figure out whether they're going to be compatible. Roughly speaking, does your rated output voltage of your preamp roughly match your rated sensitivity of your power amp? Let's move on to number 2, which was, preamp output impedance versus power amp input impedance. And now we're starting to get a little more technical, and these may not be terms that everybody's familiar with. Okay, so in general, the ideal case is I have zero output impedance from my preamp. That is, I can draw a level and it just comes really easily. And an infinite input impedance to my power amp. Now, why is that the ideal? Well, if I have the opposite, if I have a relatively high output impedance, that output impedance of my preamp is the top of what we would call a voltage divider. And if I have a relatively low input impedance of my power amp, that's going to be the bottom of a voltage divider. Input impedance and output impedance of the preamp, input impedance of the power amp always form a voltage divider. What's a voltage divider? Think of it simply this way. I've got voltage in here, I've got ground down here. And in between, I've got two resistors. And the relative sizes of the two resistors determine the input level, or the level that I get out that my power amp sees. And so I want to be, ideally, I want to be very high up on that voltage divider, right? I want zero output impedance, and I want infinite input impedance, so that the voltage out of my preamp is the same as what gets into my power amp. Now, how does that even make sense, the voltage out of my preamp? If I don't put any load on it, if I'm driving infinite impedance, that is, I don't even hook a signal up to it, I'm going to get one output voltage on my preamp. As soon as I put an input impedance like a power amp to it, well, if that impedance is small, then that's going to drag down that voltage because, relative to what the output impedance of the preamp is. So I want zero here, infinite here. Okay, and that means that the output from my preamp that my power amp actually sees is going to be the same as what it would be with nothing connected. Okay. Now, the worst case then would be I've got a high output impedance and a small input impedance, and now I'm at the near a bottom of a voltage divider, and I'm barely getting any signal through to my power amp. So in general, we're not going to find the ideal, but, solid state is pretty good at approaching that ideal. The best example I can think of is field effect transistors. Field effect transistors are nearly ideal in the sense that I drive the gate with a signal. I've got my source and whatever the other thing is, and the amount of current that goes from here through here is determined by the voltage on here, on the gate. But no current actually passes through. So that FET has effectively an infinite input impedance. Meanwhile, I can have very low on resistance, right? Once I put enough voltage on here, current flows very easily from drain to source. And I know that's a bit odd, but when we talk about source, we're talking about electrons going from the source to the drain. But when we talk about current, we go from positive to negative. So that's why they're named so like that. So gate, drain, source. I put a voltage on here, my electrons flow very easily. And so I get a very low output impedance. Say I draw the signal off of the drain here. That would be like a a common source or similar to a common emitter amplifier. A bipolar junction transistor works a little differently. In that one, the amount of current going through depends on the current in through the base emitter. Oh boy, C. What's C stand for? Oh, it'll come to me. And so it has a bit higher input impedance because current does actually go through. And a tube, similarly, some current goes through. Op amps typically employ devices such that they have very high input impedance and very low output impedance. So solid state devices can approach that ideal of arbitrarily high input impedance and arbitrarily low, near zero output impedance. Tube devices are much further from the ideal. You really have to put some design thought into getting a low output impedance from a tube device. The input impedance isn't such a problem. All else failing, you can simply stick a resistor in front of the grid for your tube. But the output impedance, getting it low enough can be a problem. And that's where we could potentially run into a problem if we are pairing a tube preamp with any other device, in particular, say, a tube power amp. Does that tube preamp have low enough output impedance to drive the power amp and the cable connecting the two? Because the cable is going to need to be driven as well. And so that, I was looking at the specs of my recently purchased Audio Research LS15, and among the specs it says, okay, what's the minimum load that it can drive? And it says 40 kiloohms. And what's the maximum capacitive load that it can drive? And that's 1,000 picofarads. And so you'd need to know, well, geez, what's the input capacitance of my power amp, and what's the capacitance per foot, say, of the cable connecting the two? And so do I need to have them relatively close together with a relatively short cable, or can I use a relatively long cable without any trouble? And if you're designing a preamp, you design with that in mind. You want to design with a high enough maximum capacitive load that it can easily drive a relatively long cable. Long enough to go across an entire room, ideally. Okay. Now, in general, if the devices are well designed, then there's not going to be a problem. And so I, for example, was looking at all of the various power amps and preamps that I could recall that I have in my collection and for which I have the specs available, and looking at the input impedance and output impedance. So, for example, the LS15, 300 ohm output impedance. That's pretty darn low for a tube preamp. But others, solid state devices, generally had a bit lower output impedance. The GTP 500 Mark II, that's my Adcom preamp. That has a 100 ohm output impedance. The Macintosh C28 has a 100 ohm output impedance. The Fisher CC3000, I'm not sure. It said 5 kiloohms, but I can't believe that's true. I think I'm misinterpreting what they're saying there. I think that actually means that's the minimum load that it can drive, or the minimum impedance that it can drive. And then we can look at, okay, well, what about the power amps? And we don't generally find an output impedance spec because we generally don't need it. We do often see what's the damping factor, which is simply the ratio of input impedance of, say, the speakers to output impedance of the power amp. And of course, that damping factor is going to depend on that input impedance of the speakers. So it's dependent on the speaker load, which we know that impedance actually varies with frequency. So we might see that the damping factor is at least such and such. So for example, my GFA 545 Mark II, the ADCOM power amp, has 100K input impedance and at least 400 damping factor. My Heathkit AA40, that's a tube power amp. I couldn't find an input impedance spec, so I looked at the schematic. And from the schematic, I infer that its input impedance is at least 100 kiloohms. And it says that its damping factor is at least 12.5. And I think that is for a 4 ohm load. The Dynaco ST70 also could not find an input impedance spec, and it says it has a damping factor of, say, 15 for 4 ohms. Phase Linear 200 has a relatively low input impedance, 18K. They say the damping factor is 100. What about my own Beaver Valley amp? Well, I don't know what its input impedance is. I haven't measured it. I probably should measure it. What's its output impedance? What's its damping factor? I don't really know. I'd have to measure it. And I probably should. Anyway, long story short, you want low output impedance, high input impedance. When you see things like what's the minimum load it can drive, that's saying, we want there to be some factor, say like 100. We want the input impedance in general to be, of the power amp, to be, say, 100 times the output impedance of the preamp. So, for example, when we look at the LS15, they say it has an output impedance of 300 ohms. They say the minimum impedance that you want on the load is 40 kiloohms. So that's actually saying that I want 4/3 times 100, or about 133 times factor between output impedance of the preamp and input impedance of the power amp. I don't know exactly how they come up with that 40K versus, just make sure it's like more than 100 times the output impedance of 300 ohms. Anyway, we're getting a bit into the weeds, but these are important. These are the things that matter, especially when you're talking about tube devices. Whereas with solid state devices, you can often just say, okay, whatever output impedance I want, I'm just going to stick a little resistor there. Now that's got 100 ohm output impedance. Okay, the third thing I mentioned was the frequency responses of the preamp and the power amp. Now, if they're both flat frequency responses, then it's just not an issue. I can add whatever color I want with equalization, tone controls, what have you. But some devices have a more colored response. And in my recent video about the Macintosh C28, I was like, this has quite the colored sound to it. And I actually measured the frequency response to determine that I was correct about the response being colored, that it, plateaued at a relatively higher level for the bass frequencies, but once you got up into the mid-range and especially the treble, it tailed off almost a decibel. So, if I have one or both of my preamp and power amp with colored responses, that's when I might need to start worrying about just the sound-wise compatibility. Now, if one is colored, say I've got a preamp with some color to it, like the Macintosh C28, and the other is not, say I'm driving something like my Adcom GFA 545 Mark II, which is, super flat output response, then as long as I like the one that's colored, if I like that color, then I'm good. If I don't like the color, then I shouldn't have bought it in the first place, right? Now, what if they're both colored? Well, we can think of it in a couple of different ways. Or, and as long as we're talking color, okay, if my preamp and my power amp are both have a colored response, and those colors are complementary, then all is good. But it kind of depends on what I mean by complementary. Say in the case of the Macintosh C28, say I really would rather have a flat response getting to my speakers. Well, if I've got that colored response of my preamp, my Mac preamp, then I might want a bit of a counter-colored response to my power amp. But power amps are, for the most part, going to be pretty lacking in color. But anyway. Now, what if the colors clash? Then that's bad. Well, what do I mean by clash? And I don't even know exactly what I mean by that, but maybe my preamp, say, let's go again with that Macintosh example, it does this. And what if my power amp is just sort of like this, and then I end up with a really low treble. And the bass and the mid-range are fine, but the treble is super rolled off. That would be perhaps an example of clashing colors. But you can also think of it just as like, well, if it's bad if there's too much of any one color. And this whole video is spurred by a comment or a question that I got from a commenter that said, I've heard that having a tube preamp and a tube power amp isn't good because then the output is just too tubey. And I had to think about that one for a second because it's like, okay, I know what you mean. Because there is a stereotypical or archetypal, what have you, tubey sound. And it's typically sort of a warm sound. Maybe, that lower mid to upper bass is a bit rich. And that might be my tubiness, still rolled off in the lows, rolled off at the very high end. And if I stack those two, then I end up with a relatively large hump in that warm range and super rolled off in the bass, super rolled off in the highs. Yeah, that would, if you don't like that much tubiness, then yeah, that'd be not good. But what I would caution you about is that a well-designed tube preamp or a well-designed power amp, I don't think is going to be tubey. Now, that's perhaps a bit controversial. Some people like that tubey sound, and I would say, fine, you can choose it. But I think really good design ought to be pretty much flat. Perhaps having to make some compromises about where the bass rolls off, where the treble rolls off, but generally being uncolored. And in that case, if I've got a generally uncolored preamp and a generally uncolored power amp, the combination is not going to be too tubey, because neither one is stereotypically tubey in the first place. Going nuts with the air quotes here. And that's, I think, maybe the major upshot of this video is not all tube amps or not all tube devices sound tubey. The ones that I can think of off the top of my head that sound particularly tubey are the cheapest ones. Like, I remember the first time I heard my first Magnavox console tube amp, and it sounded really tubey. And I really liked the sound, but it's a particular color, and I don't necessarily want to listen to that particular color all the time. And so when I've been building power amps, I try to actually avoid them having a stereotypically tubey sound. And I don't want a tubey preamp, even though I want a tube and did get a tube preamp. I don't want it to be tubey. And I like tube power amps, but I don't want them to be tubey either. Now, often with tubes, compromises in especially the ends of the frequency spectrum have been required. And maybe it rolls off a little bit in the bass, maybe it rolls off a little bit in the treble. And so you might, have a situation where you've got a bit more roll off in the bass and a bit more roll off in the treble than you would like. And if that's the case, then maybe you ought to go with one of them being solid state. Or you might simply have to spend more on your tube amp, one or the other, a preamp or power amp, in order for the design to have required fewer of these compromises at the ends. Because, compromises are often made to meet a price point. But compromises with tubes are often necessary. But there are things you can do to get around them. Often those involve solid-state devices integrated into your tube amp design, like interstage solid-state. That's a whole other subject. I've talked a little bit about it before when I talked about the Type 45 single-ended triode amp that I want to build. Anyway, now, finally, I've talked about frequency response and I've talked about, impedance, large output impedance of the preamp, high input impedance of the power amp. But what if my impedances are frequency dependent? And that can definitely be an issue. For example, a speaker generally has a very non-ideal load, right? It has big fluctuations in its impedance depending on frequency. And that means that damping factor is going to be variable. And so, the same could be true of a power amp, that its input impedance could be frequency dependent. Same with the output impedance of a preamp, that its output impedance could be frequency dependent. Now, in general, good design will make it so that any frequency dependence to output impedance, input impedance aren't going to be sufficient to negatively affect the ultimate sound that you get out. But, there could be issues, especially if you're not able to afford the devices that have required. If you don't have an unlimited budget, you might be faced with devices in which compromises were made on these things, and so then how can you know? And obviously, you should look at the specs. You can and should look at the specs. You can look at reviews. But ultimately, if you've got a power amp that you want to drive with a preamp, you're looking for a preamp, you might have to try something out before you'll really know, and return it if it's not a good match. You should feel free to do that, like, good places like, I bought my preamp from the Music Room Audio, and they have a 30-day no questions asked return policy because, you're buying it online. You can't hear it beforehand. You're paying pretty good money for a thing. You're going to want to know, and they've got a business model that can allow that. Now, if you're just buying something from somebody like me, well, generally the people who've bought from me have come to me to hear the thing. And we're not talking a large number of people. This guy Bob that I sold one of my DG SE1s, my single-ended tube power amps to, he brought over his speakers twice and ended up buying the Nico integrated amp that I was using as a preamp during the demos, bought that in addition to the power amp, the DGSE1, because he, through literally hours of listening with me in my test rig, determined that he liked that combination. And so somebody like me who's doing this is, look, my sort of business is a hobby that is self-sustaining plus a bit, right? It's a hobby that gives me enough income to keep the hobby going and even allows me to sort of upgrade my own system as a result of the money that I make, which is pretty modest, in doing repairs and selling gear and even doing YouTube videos. So somebody like me who just loves tube amplifiers, I was psyched to have him bring over his speakers because I'm just psyched about that kind of trial in general. I would encourage people to do that if they can. And B, he had some pretty special speakers, some Tannoy Monitor Gold drivers, speakers that were pretty special and were a lot of fun to listen to. And I went ahead and brought out the second time he came over, brought out a couple of pairs of my speakers that I thought were kind of special and compared the three pairs. And that was fun. So, but, upshot is, you're going to want to try this. You're going to want to try out the combinations and see if they work for you. And if they don't, return the thing. Now, me, it's a little more complicated. I've got so many different power amps, and I'm trying out this preamp with a particular power amp. Well, you know what, though? If it works with that power amp as well as it does, and it does. The combination is very nice. It's a solid-state power amp. If that preamp doesn't end up working well with any of my tube power amps, oh well, I've got a really nice combination right there. And I could be satisfied with that, at least in the near term. In summary, does Should you avoid the combination of a tube preamp and a tube power amp because the result might be too tubey? And I would say, in general, no. You should not avoid that combination, because a good preamp and a good power amp, whether it's, whatever solid state versus tubes, but a good tube preamp and a good tube power amp will neither one be all that tubey, and hence the result, the combination, will also not be too tubey. Okay, so all this is, I don't remember which commenter it was, but I thought it was a great question, because, it's one of those questions where, my first instinct was, of course not. Don't worry about it. Too tubey. What's that even? Well, you know what, though? Especially when we're getting a lot of these low-budget power amps from China that are not particularly well designed and may simply be designed to sound tubey, whatever that means. Maybe the summary of all this is, you know what? I don't recommend those relatively cheap Chinese tube power amps. I've only looked into one. It was not well designed. But I've been following Skunky's channel for quite a while, and every one of them she looks at is generally not well designed. Maybe there was one, maybe two exceptions, but I think in general she ended up modifying all the Chinese amps that she got to make them sound decent, to overcome fundamental design flaws. And she's a person who likes a tubey sound. So, yeah, there's that. Now that I think about it, there is another aspect of tubiness, and that's sort of the single-ended triode type sound, which involves harmonic distortion that you leave in on purpose. And so I could see where, yeah, if you had a tube preamp with a lot of second-order harmonics and a tube power amp with a lot of second-order harmonics, the combination could be a bit much. But I guess what I'd say again there is, like, yeah, well, if you're looking to get a particular sort of single-ended sound, don't overload on that sound, maybe. If you like a single-ended triode amp because of those overtones, those harmonics, maybe be a little wary of getting a preamp that will have too much of that sort of color to it. But I think in general, well-designed preamps and well-designed power amps don't have too much of that kind of tubiness, and you shouldn't necessarily worry about it. But I can see cases where it could be an issue. Is that enough caveats on it? All right. Well, I think I'm going to cut it off there. If you enjoyed the video, if you got something out of it, please give it a like, comment, subscribe. Hype is a thing. I don't even know how to do that, but maybe you do. If you do, give me a hype point or something, whatever that entails. I don't think it costs you anything, so go for it. Mostly, I hope you tune in again, and if you do, I'll talk to you later. Cheers. Hallelujah.